Okay, everyone wants to work in innovation. Very few understand what innovation actually means. Is it brainstorming? Is it startups? Is it design thinking workshops? Or is it something structured, repeatable, disciplined that companies use to build billion-dollar products? If you are in your 20s and wondering whether innovation management is a real career path or just a corporate buzzword, today's conversation will give you clarity on that, because our guest today has covered both the sides in the side of academia and also the industry. So we couldn't find a better person to talk to, and let's see how we can build a career in innovation management or in general in the field of innovation. So today with us we have Dr. Nikhil, who is a graduate from Lut, Finland, and works as a researcher now or a project manager, and also has been working as a consultant with companies which where he does innovation management. So this was the introduction from my side, but of course, Dr. Nikhil, please give a short brief intro about yourself.
So, firstly, thank you so much for having me here. My background basically comes from mechanical engineering first and then into innovation management slowly and steadily since 2019, wherein I discovered the master's program at Loot specifically on innovation management. And then I think the career kind of just followed in the same path all the way towards the doctoral degree in innovation management. But a little bit about myself and where this thought kind of came from. Ever since I was a child, I saw my father going into this consulting business, and he used to talk a lot about things that just did not make sense. As you said, there was something called Six Sigma, there is something called design thinking, there is something called TRIZ, there is so many tools. And I was like, what are these words and where are they coming from? Where are they exactly applied? And so slowly and steadily, maybe that curiosity led me to think that, okay, maybe it has some sort of a special place in the world, and maybe I should kind of try and understand it a little bit more from different perspectives. So that's where it all began. And now I have kind of reached, and I have, let's say, a little bit of understanding of how the field works, what it exactly means, what is innovation, what is um, the entire thought process behind innovation management, and whether it is suitable for somebody to get into it at an early age and, let's say, build upon a core foundation once you are into the field.
Yeah, that is very interesting because, in India, the concept of innovation management and innovation in general has been very frugal, to say, because we see innovation as some product being developed as a very pilot scale in some university or institute of technologies, but in general, to commercialize that product and to range it to a industrial level product from a TRL2 to TRL9, it's somewhere there where the role of innovation management comes into picture, because uh, people cannot differentiate between inventions and innovations. Invention something, yeah,
Absolutely.
it's a very very similar but very distinct terms, the invention and innovation, and the role of commercialization in between plays a very big role. So could you just elaborate how a general layman can differentiate between invention and innovation?
Well, it's rather simple. Invention is just something new that, well, okay, now there is also the problem of what do we define as new, because most of the things that we see today are not new, but it could also be new in a particular context. So, how we are kind of taught from our school and, let's say, our background of inventions are something that solves a problem, and something that's novel is considered as an invention. But an innovation is completely different from an invention, and that's why if you kind of take the entire patent landscape as a source, then in this case, patents are basically certain documents that, let's say, are the holy grail of an inventor, right? The better you are at inventions, the more patents you should have. 99% of these patents never get commercialized. That's where innovation comes in, because there are very few inventions that get to the market and solve a real problem. And so the definition of the word innovation would be something on the lines of a significant improvement across, let's say, a product attribute that's available to the market. And more importantly, the customer is willing to pay for something like that is the real definition of innovation. It covers three aspects. The first is, yes, it must be novel. The second is, it must be available in the market. And the third, and the most, let's say, important and the trickiest and the most difficult to nail, is customers willing to pay for it. And I believe that's also why a very classic example that has been stated across several TED Talks, I think, is Nikola Tesla, for example, was an excellent inventor, but Edison was a better innovator because he could find the commercial side of things. However, Tesla was just on the invention side of things. So he had great ideas, but there are different kinds of roles to play, and both, I believe, are a part of innovation management as a whole in the field.
Exactly, yes. Tesla was, I read about Tesla because Tesla was in Budapest for a long time, and then he moved from here to US, after which he did a lot of inventions there, and he had a lot of struggles in his life, maybe because he was not a good innovation management guy. So if he could have this skill to how to manage his inventions, that could have led to different scenario maybe. But coming to the part of innovation management as a career option, in India we see that it is very less talked about topic. And as you rightly said, that if somebody is a good engineer, let's say, or a good pharmacist, or a good drug innovator or something like that, it is very rare in the Indian universities that you find departments related to innovation management or even patent management, for example, because the students generally don't even realize how to invent and manage their products, and then they are running behind these, startup idea centers or something like that we have in our Indian universities, or many universities, not just Indian universities. I think many universities across the world face this problem, and very few of the universities have included this as a curriculum where innovation management is being taught at master's level, or you can graduate a PhD with. So it is, how do you see it? Because you did your bachelor's, I guess, in India, and then you moved to Finland for your master's, right, in innovation management.
That is
And
correct. Yep.
yeah, so how was your
Yes.
experience in India?
I think it was somewhere complementary. And now that I'm, let's say, on the other side of the world, a little bit in academia, a little bit in research, after my master's, I think I have a completely different perspective of what innovation management is thought of and what innovation management is supposed to be. Let's go to the first side for there. So in India, I did my bachelor's in mechanical engineering. So I was a proper engineer, right? Like we learn everything about engineering there. The problem is the starting point of an innovation is more often than not some kind of an invention or some kind of an idea. And the only way that we are taught to invent is through brainstorming, meaning you wait for inspiration to strike you, and then you, let's say, try to develop something based on that initial idea, and then you just try to kind of do the project. And the idea is not bad as such. I think it's a good starting point. However, the success rate of this kind of the method behind the invention is rather low. And most universities, as you rightly said, we do have these patent cells, we do have these innovation centers of excellence that have been established in India. However, they do not focus on repeatable methods for innovation. They focus mostly on providing inspiration. And we all know it's just like going to a gym. If you suddenly pick up a dumbbell of 30 kgs, sure, you can maybe lift really well on that day, but it's not sustainable. Instead, you pick up 10 kgs every day. It must be repeatable. So it's the same logic that applies. And I believe that Indian universities, instead of the centers of excellence that they have that focus more on the outcomes of the innovation, such as number of startups formed, number of patents filed. It would be great to have the core elements of innovation management embedded into the course structure itself, wherein we teach you the methods to invent first. So there is not a single method that we use to invent. There are different ones, right from understanding consumer needs all the way to actually solving the technical problems. Then we go to, let's say, incubation, raising of funding, series rounds, the network effects, the open innovation side of it, the business model side of it. When all of this comes together, that's when innovation management is formed, and that's what innovation management is supposed to be. In the master's level and the PhD level, you are usually exposed to this kind of approach. So I believe that Indian universities are still a little bit too narrow-minded because of that reason. Well, it's not their fault, because most of our courses are quite linear, and you just kind of follow the course structure. You pass the course, you're an engineer. So the catch here is the world does not need engineers. It needs inventors and innovators. And there is quite a big gap between them. Uh, and we are investing heavily for engineers today, but I think there is rather little evidence of teaching innovation methods, let's say, for the bachelor students. But to add on upon that, let's say a small point, I think the concept of innovation is even better realized more effectively in the childhood of the student. Let's say between the age of, let's say, 14 to 17. So just before your engineering, essentially junior college. If the training for entrepreneurship, if the training for innovation methods, if the training to solve real projects or real problems for the world can be given to children um, at the age of 14, which, by the way, is scientifically proven as one of the highest peaks of creativity in people, because as you get older, creativity reduces, and the highest peak was observed at 14 or 12. Then I believe that by the time you're already at the engineering stage, the student's mindset is such that, okay, we don't want an invention, but we want to make an impact. We want to make a difference. We want to be an innovator. We want to commercialize. Um, so yeah, it's just so many schools of thought um, coinciding together at different aspects of, let's say, the career. Um, it begins at childhood. It starts and kind of nurtures in the schooling. Then between the junior college period and just about the first or second year of engineering, you get some basics of how things work, but not why things are supposed to be like this. Then you get some ideas about something about innovation. And then in master's and PhD, I think you really come to know an entirely different world that you thought that was so small. And then you are ending up in a sea. And sometimes it's quite overwhelming, even for me, for my master's. I thought that, oh, yeah, there are some methods that we have heard of. There is design thinking, let's say the most common one. Six Sigma, we've heard of it. Lean, for example, we've heard of it. And then when I came to Loot for my master's, I learned 7 or 15 different methods for the same exact task, let's say, just for idea generation. For the same exact task, such as needs identification, there can be consumption chain analysis, attribute mapping, design for X, let's say. There is TRIZ, there is jobs to be done with different schools of thought. And then you're landing in this ocean of methods. But then the innovation management, let's say, definition changes a little bit. It's no longer that innovation management is new, but a good innovation manager knows when to select the right tools available at his disposal, just like a cricket team. You want to select the right players suited for that task, and you have several options. I think the real skill of innovation management is in this particular task. And if you can nail that, I think all of the other aspects are automatically sorted out. So you would be a good inventor, and you would also kind of be a good innovator all by itself.
Exactly, because as you very deeply and correctly analyzed this situation, and I think this is also a problem with what I was trying to say in the terms like when students in the Indian universities try to build a product, they just focus on uh, something new. Okay, but something new comes with what intention? What problem are you, what specific problem you are going to solve with it? For example, our final year projects used to be like build a prototype of some working model of something. But if wouldn't it be nice that if it is part of curricula that they solve the problem from the beginning and they understand the rationality behind it, that okay, when you are trying to solve, these are the nitty gritties which you will have to face in between. Not like that you developed a product and then you want to commercialize it, you are seeing that okay, the business model is not feasible for this product, then you lose the all the effort you made one full year to made develop this product. You put a lot of engineering and in the end it goes vague. That idea. Okay,
Absolutely.
I am very much in favor of trying and failing, but that can be also a part, because as you said, the structured part of innovation management, there must be ideations which fail, right? After
Correct.
some iterations of ideation, you will pass one or two products will pass, which will make the benchmark requirements, and then the but if you are following that structured path, then you land up with something fruitful for the society, for the college, for the humanity in general. So okay, but let's move a little bit away from it, and let's talk about TRIZ. This is something many people wouldn't have heard. And what is it, how it works, and how you got into it?
So, to give you a very simple definition of what TRIZ is, it is a set of tools that helps you solve problems. It was developed for technical problems in the first place. However, you can solve business problems as well. It stands for Teoria Rashenia Izobratilisk Zadash. In English, that's a Russian acronym, since its origin is from there. But it stands for the theory of inventive problem solving. And the story is actually something that's so inspirational to me that um, it's still taught in many schools. For example, in LUT, TRIZ is part of a compulsory course in the Global Management of Innovation and Technology program. And the story is such that somewhere in the 1960s or 1970s, just after the Second World War, there was a gentleman known as Genrikh Archuler. He was from Azerbaijan, Baku, if I'm not wrong. And he was a patent attorney, a patent lawyer. And his job was quite simple. See the patent application, stamp something, okay, go ahead. It's a very classic desk job. And one day while doing this, he used to scan a lot of patents, right? So naturally, he came across a lot of solutions and this kind of invention. So it fell into his lap in a way. Um, and one day, once he was observing all of these patterns, he realized that why are certain solutions that are provided, let's say, in one industry, also seen in an industry very far from it? To give you like a modern day example, it could mean like, hey, why are certain technologies that are used in, let's say, televisions, used in mobile phones? Why are some things that are used in mobile phones used in the shoe industry?
Mhm.
It doesn't make sense, right? uh, they have nothing to do with each other. The entire competency needed to, let's say, develop products in a shoe versus in displays is entirely different. And yet we are seeing some patterns. So then he kind of started investigating, is there a science behind it? Is there a way to uncover these general patterns and maybe build some sort of a theory wherein we could invent, but it could be more predictive, it could be more solid, it could be more concrete. And he was always of the opinion wherein number of ideas being more is not really a good metric for evaluating how inventive you are. Ideally, we just want one idea that works. So if you were to have like a numerator and a denominator, you want one idea that works and one idea that you generate. That would be like the most idealistic case in for any inventor, right? The first idea you get is perfect. But unfortunately, that's not the case. We always end up with, let's say, one out of maybe 30,000 ideas by research standards at least. And then one of them gets commercialized. And then he came up with, okay, we need to start working on this and understand why do we have these patterns. And then he found something called as contradictions. When there is a certain positive effect that is related to any sort of, let's say, design, then there is usually also a negative effect. If you were to abstract this positive and negative effect, then you get something like a technical contradiction. And if we were to find the contradiction, then a pattern emerges. And then they found, okay, certain patterns apply to certain problems. Meaning, if the shoe industry is facing a similar problem, then maybe the TV industry also must have faced a similar problem. And automatically, they kind of applied this solution. So that's where TRIZ originates. This was developed, and in fact, it's still developing, but up until the point of 1995 or 2000. And then TRIZ, as it stands today, is having a lot of iterations and evolutions. It has now gone to modern TRIZ, wherein it has actually become a very core part of innovation projects in the consulting industry. For example, it used to be a tool for simply solving problems, but it has now evolved to something like, do you want to identify what are the customer needs? How do you know whether it's the right customer need? Do you want fewer but higher quality of ideas? Would you like to improve speed to market? Do you want to reduce the cost of a product? Do you want to reduce, let's say, or develop a completely new product itself? Do you want to improve a parameter in a product? Do you want to find an adjacent market for a competency or a technology that you have from areas far away from you? So you see, these are all innovation related tasks or subsidiaries that usually CEOs or CTOs handle. And somehow TRIZ came to kind of have this set of tools that supports all of the innovation management projects that we typically perform at a very senior corporate level. So that's its history. And how I got into it is at a very young age. At the age of 14, I was about in ninth grade. And the story is such that my father happens to be a TRIZ professional and an expert. And once, or let's say every day, he used to give me a small exercise to do. Something like, hey, what kind of properties does this mobile phone have? Oh yeah, and then I will given some sort of structure to work on it. It has a nice design, it has 3 cameras, it has a color, it has a nice texture, so on and so forth. And it was fun. Later, I realized that it is part of something called as CID, or Creative Imagination Development, which is a supportive tool of TRIZ and helps you to solve problems. So at the age of 14, we experimented and we solved a problem that happens in Holi. So Holi is a pretty big festival in India, and the
Coming
story is
soon.
such that we usually have water balloons, and you fill water in them, and then you pack them in these plastic bags and you throw them, and it's like it's fun. And once what happened is we were kind of just sitting on the balcony, and he's like, let's try to solve this problem, because the problem is after Holi, it's a really big task to collect plastic bags. And we kind of solved this problem through TRIZ. He was simply guiding me, not giving me the solution. And the solution that we came up with the TRIZ was, somehow all the water balloons must be picked up all by themselves magically. And on top of that, people should fight with each other to pick up their own plastic bag. So, and then he kind of says, so what do people fight for if something is fallen on the road? I'm like, hey, money, well, of course. And then the catch was, okay, so the plastic bag that's on the ground must have value. Let's say it should be worth like a diamond, and yet it must have no value. It's just a plastic bag. And then the idea struck that, oh, what if every bag has a lottery number? And that lottery, let's say, contributes to a huge amount. In this case, people would fight for the bag, and you must throw the bag and collect the bag and submit it somewhere. In a way, then you also have the cleanliness done. And let's say we give a reward. And that solution was so brilliant that it's really simple and elegant that, hey, why didn't we do this in the first place? And that's how it kind of evolved. And once I got into TRIZ, I got my certifications from an official body somewhere around the age of 17. So just about in the bachelor's. Then using TRIZ, I also solved for my final year project a problem that happens in Pune. I've got a patent for it with my professor. That was my final year project. And we also fabricated it as part of my final year grades. And it was like the top 3 projects in our university. And then I think I just decided that I like this path that I'm on, and I would like to explore more, because at that point of time, I did not know about the other methods that exist in the world, such as open innovation or anything like that. I knew TRIZ. And then I think my dad and a lot of the other experts that I usually work with, they said that, there are other tools, and a good consultant or a good thinker knows several tools and picks and chooses the ones that he likes. Currently,
Mhm.
one of them. So I think it's time to know several ones. And that's how ended up in Loot, knowing too many of them. And now, yeah, now I can maybe be a little bit more comfortable in that domain. So that's the history of threes. So as it stands today, Loot has some programs that have threes as a mandatory part, but it's not just Loot. For example, did you know that Massachusetts Institute of Technology
Mhm.
has a special course called Design for Patentability that is run
Mhm.
by a threes master as the highest,
Wonderful.
let's say, level of mastery. Some other courses in Australia are already doing it. The
Mhm.
University of Netherlands, I believe Twente, is already doing
20,
it. So
yes. Mhm.
there are small hubs that have now recognized the value of threes. I still believe it is a thinking structure, but the thinking structure is so rule based.
Mhm.
That's what makes it different. Instead of relying on inspiration, we rely on a set of rules that, okay, let's make a function model. So then you have a certain tool and you must apply all of these steps without skipping anything. And then you trust the process. That's the way we say it. Just follow the methodology. Um, yeah, I think that's its biggest strength. It somewhere
That's
teaches you to follow how to think.
mhm. That's a very classical example of yourself you gave about solving that holy problem or the plastic problem. That's very, very interesting how at a young age students can learn to think differently and to solve problems in a structured manner. I think even it should be taught at a high school level to some extent, just a basic. But when people at least realize that there is a structure for inventions and innovations, it becomes more easier to innovate rather than randomly, like the atom particles randomly moving without any direction. So I think it gives you a direction to some extent.
Absolutely. I think
Wonderful.
we
Yes.
we had some experience in it, and in high school, basically the way it's taught, and it's already taught in some European universities. Um, Children from the age of something around 9 to 12, so really small kids, maybe in like sixth grade or fifth grade, are given certain assignments to develop their creativity, and they don't look anything like problem solving. For example, there is a set of tools. I believe it came from OTSM, which is another version of threes, General Theory of Powerful Thinking. He used to work with students a lot, and there were very weird exercises. For example, there was something called as size time cost operator. And I was like, okay, what is this? And I was taught about this. And the idea was amazing. The idea was you are supposed to choose a product that you like in the world. Anything you drink, anything you eat, whatever. And basically, you just do three things. You increase the size of that particular product by 10 times, 100 times, and to infinity. And think and visualize and write down what do you think the world would look like if this product, for example, for me, my product was coffee. So I love coffee. What happens if the world has 100 times or infinite amount of coffee? And then you have to make a scenario wherein you have to really think, oh, maybe instead of water, coffee runs in the pipelines of the building. Coffee becomes the next water. Coffee
Mhm.
becomes cheaper than anything else. Coffee cubes could be used in airplanes instead of some. And you kind of come up with these scenarios. So this is the size aspect, but you also go the other way around. You reduce the size of that product by, let's say, 10, 100, and to infinity, meaning there is only one molecule of coffee that's available in the entire world. What would happen? And then, like, yeah, the demand would rise quite a lot. It would be really expensive to buy it. If you have it, you are basically the richest person in the world. And then you had this size. Then there was also time. What would happen to coffee over time in the future? And how was it in the past? That's 100 years, 200 years, 300 years in the back. And same with cost. What if coffee, one small bean of coffee, becomes billions of dollars? And what if coffee's value is basically nothing? Even if I give you free coffee, no one's taking it. And children were asked to create scenarios out of this thing. It seems like a very stupid exercise, but it does something that really expands and opens up their minds to inventions and inventive thinking. Um, we call it psychological inertia. basically every inventor or every engineer has a mental block that he faces during problems. But that block, when you say out of the box, it's not so easy to jump out of the box because your mind is thinking in a certain pattern. It's necessary to break that pattern of thinking. And these tools specifically, that were called as creative imagination development, was to expand the box bigger. Essentially, the world becomes your box, and your psychological barriers are a bit lower when you try to solve real problems. And we saw a real effect of these when we kind of, I think, piloted some of these. And there are some research papers about it, that there was certain pilots that were held at this age. Children were asked to draw sometimes, children were asked to write sometimes. There were different tools, and they saw a huge difference in their neurocognitive levels. Meaning,
Mhm.
when you generate ideas, there is a scientific effect that your brain registers spikes when you get an idea. The number of spikes basically counts how active your mind is while solving the problem. With all of the other techniques, it mostly remains that there is an initial spike with inspiration and then it kind of declines. But with creative imagination, kids, the spikes were constant, meaning it goes up, it comes down, and it again goes up and it again comes down. So you are essentially driving your neurons better. So somewhere in your
Mhm.
hardwiring, you are more creative by research, and that we found that was like one of the most important findings of teaching these kind of techniques at the high school level itself. Um, and that's why it's often said that startups innovate more than, let's say, multinational corporations, because most startups are really young, also started by a lot of young people, and they require an entirely different kind of a mindset. And it's possible that when the owners or the founders of the startup were, let's say, growing up, they went through something similar or some experiences that create this kind of a trigger. But in multinational corporations, is the other way around. Everybody is just used to the same style of thinking. So nobody can think outside the box. So yeah,
Correct.
lots of little correlations from one field to the other are somewhere visible.
That was a very interesting example of this coffee. If there is just 1 gram of coffee left on Earth, or if there are like so tens and thousands of 10,000 tons of coffee, as an so best case scenario and worst case scenario. So I could only have the analogy of sometimes few hundred years back, India used to trade spices the similar way. Like spices were so black pepper was so rare in European countries that people used to even trade gold with black pepper. Mm, if
Hmm.
somebody at that time would have done this scenario, we could have been in a better situation. But anyways,
Absolutely.
so it is relevant, and it is very quite interesting how this neuro pathways can, or neuro muscles can be trained in a way that your creativity spikes. It's very interesting. Moving forward, how do, because you have worked with as a consultant also with the companies, and you just mentioned the role, or the way the startups work and the big conglomerates work. So they have a different mindset. And how was your consultant as a innovation management consultant to companies? What is struggles they face? And if somebody is looking to make a career in this, what is skills do you think they should be willing to develop in order to get into this kind of role as a consultant?
Okay. Several questions kind of embedded in. I'll kind of try and answer them like in a structured way, if I can. So in consulting, usually we get a lot of vertical. Well, we get a lot of horizontal experience actually, because for example, my first consulting, and this I'm talking about R&D consulting. There are two types of consultants in the world. Usually, there are some strategy related consultants. They are the usually big four companies that we usually talk of, and then you also have R&D consultants, which do research and development tasks, and they're kind of like an extended arm that companies can hire for a certain project. Some examples in Germany, for example, are EDAG. EDAG is very well known for that. Um, and in R&D consulting, my first, let's say, role was to go and improve some sort of a color variation problem in a textile industry. Mind you, I know nothing about textiles. I'm not a textile engineer in the first place. And yet this project had landed in my lap. And the project was completed, everything went fine. And then the next project that I was put on was related to batteries. And then I was even more scared because I know nothing about batteries either. So I think in consulting, you get so much of cross-industrial experience because one project could be related to tables, another one could be related to semiconductors, and yet you must solve these problems, even though you only have a degree in mechanical engineering, right? So
Correct.
as a consultant, I don't think your engineering degree matters at all. What matters is your scientific logic behind it, or what kind of innovation methods you learn in conjunction with your engineering degree. So, of course, I'm not saying neglect it, but something else is needed that helps you adapt to different industries. It comes with experience. For example, the next project that I was put on was medical sector, and I know nothing about the human biology, tissues, nothing like that. It was about some sort of bone replacement or hip replacement product that has to be improved. And it's an entirely different context, entirely different set of variables that you deal with. And the more important part was the nature of the projects is also quite different in R&D consulting. It can range anywhere in between, okay, we want to develop a brand new product from scratch, something that just does not exist in the world, all the way to we must reduce the cost of the product by, let's say, X%. Sometimes it's about we have a product, it's not doing so well in the market. They know that the, let's say, product is about to die or the market's too saturated and we cannot really grow this. But this product has a big factory behind it. And the idea is, what else can we manufacture which is very similar to this product in an area that's far from it? So it's very similar to this blue ocean strategy that we hear, establishing a niche for existing assets as a type of an innovation project. And sometimes it is absolutely at the C level, something called as innovation portfolio analysis. Now, we all know that we cannot innovate every product that we have in our portfolio. That means there are some decision makers that decide, okay, maybe we should place 20% of our money on horse number A, 30% of money on horse number E. But how do companies actually decide that? How do you know what to invest in and whether the technology would grow, whether there is a market for it 5 years down the line? What should we innovate on is the real question. And it's one of the most difficult projects to execute in the world. But thankfully, I had at least some insight into how it's done currently. And so, yeah, it's quite a wide field in R&D consulting experiences. And let's say that most of my engineering experience only helps to understand the physics behind something, because you really need to know engineering. To be a good R&D consultant, I would say purely business backgrounds are less suited for this kind of a task. You must be at least some kind of an engineer to understand any phenomena that's happening with the product or the manufacturing process. And on top of that, you also need to be very well informed with innovation methods or problem-solving methods such as TRIZ. Different kinds of consulting companies have different methodologies. For example, some of them are supply chain consultants. In that domain, you need to know supply chain related methodologies. So it can also kind of help towards cost reduction projects. So it kind of connects to innovation management. Most people also think that R&D consulting is only about product innovation and process innovation and nothing else. That's not necessarily true. I believe that it spans all across even strategic innovation in a way where, okay, what should be the product strategy in the line? Or let's say if you have 10 features that you have listed for the product improvement, let's say the company has gone and made a survey. Our job, for example, in my case, was to decide which of these 10 features makes the most sense and which of them is the true hidden need that the customer is not explicitly saying. That generates a wow factor. And a very common problem that happens in all companies is they don't know the customer need. They spend a lot of money, they spend a lot of market research, and when the product is developed, it reaches the market, it still fails. And all the senior leaders usually attribute it, saying that, hey, we just developed a product that nobody needed.
Mhm.
I think that's where the core of all problems begins. So it's a really critical step. But to understand that particular need, you need to know engineering as well, because you have to go to the grassroots. How does the product actually work? What kind of resources are available for the product to deliver that particular function or this parameter of value that we're talking
Mhm.
about? And then maybe work your way uh, forwards from there. So, yeah, I think pure business, not a great idea. Pure engineering, not a great idea. You need to be somewhere in the middle. That's exactly when we say this. I'm an industrial engineer. That's the term
Mhm.
that's usually coined. Somebody who knows engineering side of things, but also knows the business side of things. The business conveys the story or provides a case, essentially, to support your engineering findings better.
Mhm.
Um, that's the ideal, let's say, sweet spot you want to be in if you would like to have a career in consulting. A little bit and best of both worlds. And you're a generalist. Essentially, an R&D consultant is never a specialist kind of a
Mhm.
uh, consulting domain. It's a generalist kind of a domain, meaning, you know how you have this saying, they
Mhm.
say, jack of all trades and master of none. You are exactly there.
Mhm. But with a logical reasoning mindset, you need to have that big to solve that
Exactly.
problems. Mhm. And so, if somebody is listening to us and who would like to make a career in this sector, do you think there are some institutes in India where students can apply? For example, a fresh graduate, let's say in any field, probably engineering or related fields, and they want to become a consultant. Is there a pathway that they can follow in India or abroad? Um, can you give some examples like where they can apply for a course or take up a master's degree or something like that?
Absolutely. Even in India, there are certain courses. There are also certain associations that kind of help with this kind of task. For example, we have an association that we set up called TRIZ, Association of Asia. It operates mainly in India, and it is mainly created for helping universities and kind of provide kind of a mentorship program towards innovation, where we teach you the innovation methods on your own projects. So hands-on learning cannot be substituted, but we can at least do a little bit of
Mhm.
hand holding there. But I think the best way to start off, since threes is already quite an advanced level,
Mhm.
the bare minimum basics that I think every student, if you want to get into R&D consulting, is Six Sigma. You need to be uh, at least trained in Six Sigma, maybe Lean, maybe even design thinking. These courses are
Mhm.
available online, even on Coursera, actually,
Mhm.
on these online platforms. Um, Sometimes the governmental institutes, for example, the Indian Statistical Institute, provides Six
ISI.
Sigma courses. Yeah, exactly. ISI provides a lot of courses on Six Sigma activities and even entrepreneurship cells and all of these
Mhm.
associations and networks that they have. That is an excellent place to start.
Mhm.
And if not, I'm pretty sure that at this point, every university has kind of a community of students and a community that can come together and request for these kind of courses to their
Sure.
principals or their program managers. And in fact, the university would be more than happy to help out the students, since it is a very student led initiative in this case, that, hey, the students really want to learn
Mhm.
something about innovations. And university, more often than not, does have a lot of contacts, networks, experts, even company professionals that can come and train
Mhm.
students in a certain skill. So everything comes down to what makes an R&D consultant different is not the engineering, but it's everything around it.
Mhm.
The projects that you do matter. The application of your skill matters even more. If you can even take up, let's say, online competitions, I would say that you should absolutely do it, because you will learn so much from those experiences about innovation. There are certain competitions that are run by Tata Group. There are some of them that are
Mhm.
run by these websites called Nine Sigma, and these are kind of these crowdfunding or crowdsourcing rather. organizations wherein there is a challenge, let's say put up by General Electric to the world, and you just try to solve this challenge by yourself. So yeah, it really helps. And abroad,
And
I think it's a little bit different. Let's say, for example, in our university, the way we learned it here is there are some websites called as MOOC platforms, MOOC.
mhm,
MOOC usually means that it is an open platform where anyone can come and learn.
mhm,
There are also this open university concept platforms wherein students can simply go online, take a credit, and transfer those credits to their university as well. And most of it is just self-learning. Second one, I think you know the best, is attending and applying for, let's say, spring schools or these summer schools. Typically, all of the budget costs, let's say for the travel and
mhm,
everything, is at least covered by the university projects. And the
mhm,
goal is exactly this exposure and internationalization towards innovation. And there is a lot of
mhm,
European projects that go on between thousands of universities.
mhm,
And I think Indian students don't necessarily capitalize on them because they are unaware of them.
mhm,
Uh, Europeans do know about them. So
mhm.
they are usually
I
the ones
think
that are targeted.
even in many European universities, it is not so popular because I am teaching to many masters, bachelor's students, and when I ask them, "Do you know about these opportunities?" and they went blank, and I was like, okay, it is not that famous here either. So but I think so as you correctly mentioned, if someone wants to build a career in this, they should start with some projects and taking Six Sigma, as you mentioned, for the certifications. And I think that could be a good start to realize also, are you really into this or not, or you are just trying, So after Six Sigma,
Correct.
at least you will be pretty sure that, this is my cake, I can follow it further. And then, as you suggested, there are some universities like Louth, Twente, and some in Australia. I think many European universities has this. If people do a little digging on the Google, they can find some very good universities where you can do masters or even PhD, but that is for the academia side. But even after your masters, I think the students can go for the industrial roles, uh, because in many of the West EU countries, there are requirement of such consultants, because, for example, I was in Estonia, and there are so many digital startups there, and they keep looking for such roles. So you never know. And okay, so that was for the students, and I have one last question, which is which I ask to all my guests, is about because it is also very related to your field. How do you see innovation changing when in the context of AI coming into picture?
Oh, that's such a difficult question.
Because you know
Well,
why
okay.
just one more thing. You know why I asked this question? Because I recently heard Sam Altman and some other top-notch guys from the AI industry. They were saying that it is possible to be we can see in 1 decade a one-person company, and that company could be $1 billion company.
Absolutely.
So
I think
how?
I believe in that. Um,
Yeah, and
Here is the state.
just to give
Yeah,
another
please.
context, that um, innovation, since innovation is not let's be clear here, that innovation is not always about product, that you build
Hmm.
some product. Any new process can be a new product, or a part of innovation. So here we are, when a simple MacBook can run a full company, and you can solve problems using the AI. So it is for sure going to happen. But from your perspective, you can tell, like, from the innovation management perspective, how it will be going to.
Okay. Here is the current state of innovation management as of now. If we talk about, I would divide it first. The first part, usually in every product development process, is idea generation. Most of these tools, such as design thinking and let's say even threes, are respect with a better idea or a better and a more complete idea that works, that is more efficient and everything. But the problem is the method can be learned in 2 days, but the application of the method takes years. I mean, you
Mhm,
can learn threes in 3 days, but
mhm,
to apply it, it's really long. It's as good as saying that, can you play a piano? Yes, but can you play
mhm,
Mozart? No. The problem that I have now noticed is all of the innovation methods that exist in the world require practice. And students, rather not even students, companies don't have budgets nor the time for practice anymore. I believe that the AI would substitute a lot of these idea generation related methods soon enough, uh, because it's simply faster. You still need to know TRIZ, but not to the level that you know the precise way of how to apply it. More or less, the AI will do the job for you. Because what matters at the end of the day is your KPI is tied to, let's say, did the product go ahead or process go ahead? So
Correct.
those parts, absolutely yes. AI has a significant potential there. Not just AI, and I'm here kind of going one step further. I think it's agentic AI that really,
Yes, AGI, yes.
it's really going to change, because okay, what are AI agents? AI agents are things or AIs that kind of take action on behalf of you. They usually hallucinate much lesser because they are dedicated for a certain task. And there are already some innovation related AIs that have been developed. So tomorrow, if you were to come out with a new agentic AI that would, let's say, build a platform for you specifically for, let's say, innovation management and idea management, you're already doing great. Those parts, absolutely yes. The place where AI can help you decide is also in somewhere related to the fields of strategy and portfolio management. It's simple because what's the strength of AI? It can hold much longer memory and it can go through your data much faster than any number of people can. That's the biggest two strengths. Wherever we require these two things, wherein there's a lot of data available and we have to make a decision based on that data to proceed, AI can easily substitute that and give you a certain recommendation of what you should do. It cannot make the decision by itself on behalf of you because that is still someone's role. But yes, it could do that. However, soon enough, and I'm not saying like soon in the sense the next 5 years, but when people have usually said that AI is the new, well, English is the new programming language.
Yes.
Basically, AI is a PhD guy in your pocket. It knows everything about chemistry. It knows biology. It is a consultant of sorts already. If you know how to use it, and I'm not talking about prompt engineering. Prompt engineering is just one of the small ways of enhancing it. There are way different methods that you can learn just by prompting it. And let's say improving the base models inside the AI as well, using your own knowledge and creating your own agents. I think that would work really well. But if tomorrow, currently we have one AI that operates, let's say you use ChatGPT, Gemini, whatever, right? Soon enough, we will have models that will come up as there is a prompt, you have a problem to solve. It will go to 5 different AIs. The 5 different AIs will fight against each other to figure out what's the absolute truth and then provide you an answer. So you now have power of 5 AIs with one, let's say, question. I think Perplexity has already implemented it. It's called as a model council where they fight amongst each other to give you truth. That's the first step. The second step would be AI that is integrated just like an IoT device, right from decision making in a company all the way to your workflow and at the factory floors. Meaning the machine would already know what is supposed to be done. It could take action on behalf of you. It could do the production on behalf of you. If there is a problem in production, it could even recommend what my problem is. So it's like a self-diagnosis that's happening. And all of it essentially gets tied to innovation management. What the AI cannot replace is your learning out of it. A lot of people fear that if you use too much of AI, even for innovation related tasks, I'm not thinking anymore. The AI is thinking for me. It's not true. I think that is the worst. Then you're using the AI wrong. The AI is supposed to improve upon your own thinking. So
Exactly.
every
I
single
think
time
there is a
you give
yes,
a
sorry.
response, every single time you, let's say, type something into the AI and you get an output, hold that thought in your mind and really think about how does your experience contribute? Can I make an improvement to that AI? And it will improve itself as you do it. And that's where your thinking will develop. So yeah, I think in all innovation management tasks, AI can be a really good decision support system, but it cannot do and take decisions on your behalf at any point of time.
Because the next step from AGI will be super intelligence. That is the last stage of AI evolution. Once we reach there, I don't know humanity will survive or not, but we will see how it goes. But we are really into a very interesting spot of human evolution and how the technology evolved, because from here whatever innovation had till this point will now exponentially rise. So what kind of innovation we saw in the last
Correct.
100 years, 200 years can be now done in 5 years, I guess. So that is a very sharp rise, and we need to be smart enough and working constantly to improve our skills. And as you said, the human artificial intelligence combination, the HAI, so I think that is the best combination, because as you rightly said also, that AI cannot take away your experiences from you. I mean, the color palettes your eye sees and a story behind that color palette, AI doesn't understand that. Okay, it is trying, but you have your own story. Your lived experiences cannot be changed, and your lived problem solving attitude and things, how you perceive and create a solution out of a problem, is very different from a machine learning way of solving a problem. So it is very interesting times we are living in. But of course, I hope this podcast will be helpful for the youngsters all around the world who wants to build a career in innovation management in some way. And it was very interesting talk. I wish I could take it further, but we have time limitations, and maybe we will keep it for another session sometime, where we discuss more on this AI aspects or the dimensions, that how really it is going to affect, and what could be the potential solutions from the R&D sector or the consultancy. What new tools, skills need to be co-developed alongside the development of AI. So thank you, Nikhil, and we hope to meet soon.
Thank you so much for having me here, and thank you so much for being a great host.
Goodbye. Thank you.